Vert.x and Red Hat OpenShift. This session demonstrates how the combination of Vert.x and OpenShift makes the development, deployment, and management of microservices burn less. It's a slideless session, pure live coding.
Okay, so yeah, no slides. That's my third presentation here. You have seen yesterday and this morning lots of slides, so it's time to see some code, right? It's time to see what we can really do with Vert.x and how does the combination with OpenShift will really change how you are building reactive system. That means distributed systems that will be responsive, elastic, resilient, and all based on asynchronous message passing. So I will start by, so I will be here because I need to code. So I will start by creating a new module. I'm going to use the Vert.x Maven plugin to build my Vert.x application. It's not mandatory. You can use whatever you want. It's just convenient. So me.sco. I fill this super form. Yes, shopping backend. Oh yeah, and I forgot to say, I'm going to fix the first world problem we have is how you manage your shopping list. Right. We all have this issue. You think that you are the only one to write on this shopping list, but actually no. You are probably the only one that reads this shopping list when you go to the grocery store. And to build this system, we are going to build a couple of microservices to try to see how everything fits together. So here is my Maven project. Nothing very interesting here. I will use the Vert.x Maven plugin setup goal that will add it to this form a bit of Vert.x flavor. Here it is. Well, let's take some risk. It's a live coding session. So let's use the latest development version of Vert.x. This will be fine. We have the Vert.x bomb. We have a couple of dependencies. We are going to add some dependencies. So what do I need? I will need Vert.x web to build a REST API. I won't use it right away, but that will avoid, I will use a Vert.x Redis client because you probably need some data source at some point. Because we're running on the cloud, I'm going to use Vert.x Service Discovery. Here it is. What do I have? Vert.x, oh yeah, it's Service Discovery for Kubernetes because OpenShift is a layer on top of Kubernetes, so I will use this and you will see why. Yeah, I should not forget SLF for J, SLF for J API, yeah, any. That's all, that should be fine. Let's see, maybe I will add some. This is the Vert.x Maven plugin here. It's already configured. I just want to add one small configuration, so it will be much more fun for me. I will enable the redeploy by default. All right. Okay, now I just, oops, not here. I need one other property. It's a Vert.x vertical. That will be the entry point of our module of our microservices. Me.demo.shop my shopping backend. Yes. Okay. And now I go here and I will just create this file, this Java file of new. That's all. So it's a vertical. A vertical is just a Vert.x component, and in Java you just do extend abstract vertical. It has a start-stop method, but I just need a start here. And what I will do is that I will create a router. Okay. And Java 8. Yes. Okay. IntelliJ. And this router will let me do things like get on slash handler c.response not and hello. Okay. Once I have a router, I need an HTTP server. Fortunately, Vert.x provides an HTTP server. Every time that there is a request, the handler we will pass here will be called and will dispatch a request. We want the request to be dispatched to the router, so we just do router accept. That's all. And we will listen on the well-known 8080 port. There it is. So let's try this and let's see if it works or not. Vert.x run. Oops, no, sorry. forgot compile. If I don't compile, that's not going to work. Compile, yes. So the Vert.x Maven plugin will, in that case, won't even package the application. It will just say, oh, that's your vertical, and we'll just start it and see if it works. So if I go there now, I should have hello. Great. That's not a shopping list. So my shopping list will have a very simple model. It will be a map. The key will be the product, and the value will be the integer, which is the quantity of this product I need to buy. I don't care about the order, so I will just create a hash map. Okay. And now I need a couple of other routes here. For example, if I do /shopping, I want to have the shopping list. Get shopping list. Okay. Now, if I do a post on the same URL, I want something to do this dot add to list. Something like that. And if I delete something, so I will use a pass parameter to detect which product I want to delete. So a pass parameter in Vert.x Web, just colon and the name of the parameter. And then I will do this dot colon delete from list. So here I forgot that one. Oops. So here you see that there is some redeploy going on, but obviously it doesn't compile, so it won't redeploy anything at that point. So let's write this one. So my shopping list, I would just do get the response, then end with the JSON representation of my list, and for this, Vert.x provides a JSON utility where I just do encode list. That's all. Add to list? Well, add to list won't be much more complicated, right? Add to list will just do, well, I need the body. Oh, I need the body. So I need to do something first here. I need to configure the router with a new handler, which is the body handler, because by default, Vert.x, for performance reason, is not passing the body. If you want to pass the body, you just need to add this line, and that's all. And once you have this, I will get body as JSON. Oh, that's my body, JSON. The product name will be, well, let's say in the name field of my JSON body, okay? And the quantity will be in the quantity, and if omitted, then I will just say 1, okay? And then, well, then I just need to add that to my list. Name, quantity, fine. What do I do then? Then, well, that would be nice to display the list, so I will just call get shopping list, passing the request context, and I'm done. So where is the last one? Delete from list. Okay. So delete from list has a pass parameter which is name. So I will extract it, pass parameter name, okay, and I will just do list.remove this name, and then just say, well, get shopping list. That's all. That's all I need. So now it's compiling here, and if I go there, I don't have anything in my shopping list. So let's try to add some stuff. Let me go there. So I will use some HTTP stuff. HTTP. Yeah, perfect. I need some beer, or I need more than one beer. It's my third session. Come on, I need at least 24 beer, right? Resource not found because I forgot one thing. Show ping. And this is my current shopping list. And if I go back here and do that, I have my shopping list. Let's add some coffee too. It's my third session. I just drank a coffee, but let's say just one coffee. Let's see. Fine, it works. And let's say the delete command, does that work? So I will just do a delete. And I will delete the coffee. Maybe I had too much coffee today. Fine, we have just beer. And if I go back here, fine. Okay, so now I would like to have this, but on OpenShift, right? On your cloud. So in this first module, I will use Docker build, just that you understand really how it works. So the first thing to understand is the Vert.x Maven plugin, if I do this, is going to build a fat jar containing Vert.x, all its dependencies that I've declared, build that, and this is a runnable jar that I just have to do java.jar. To deploy it on OpenShift, I will use a Docker file. Or actually, I will just copy it because there is nothing interesting in a Docker file at this point. Up. Docker file. I will command that. Oops, no. The content would have been much better. Not just the name. So it's a very simple Docker file. I start from a Java image, so providing Java. I copy the file that has been built to this directory here. I export the port 8080, and then to launch it, I just do that. This part is kind of tricky because Vert.x by default is trying to write things in the current working directory, which is not allowed in OpenShift, and actually we should not do that. So what I just say is, well, your cache, do it in /temp. Anyway, it's immutable infrastructure. As soon as we kill you, you're lost. So I won't run Docker here. I don't even have Docker on my Mac. What I will do is that I will send this to OpenShift, and OpenShift will build this for me. So I have a script for that. Yes. So what it is doing is that it's creating a build object on OpenShift here. So this is my OpenShift. This is a project where we have stuff, but we will explain it. It's create a build. This is this one here. This build, so how does that work? The commands that I've launched take the whole project, send it to OpenShift, and say, well, start the build. And OpenShift look and say, oh, there is a Docker file. I know what to do with the Docker file. I will build a Docker container. Run the Docker build for me. So it's running on OpenShift. Do all the things, so the from, the work dir, expose, etc. Create the Docker container. And then my script is also going to create a bunch of objects. The first one it will create is a deployment config, which is kind of a manager that will make sure that we have one instance of our application. The second thing is, well, the instance of my application, here it's a pod. They call that pod. So here we have it. And we also need a service. This service will expose a feature provided by my container to the other people, to the other component of my system. And normally inside OpenShift, and as I wanted to have access from outside, I also created a route that, here we have hello, and if I go to shopping, well, I have my shopping list, but my shopping list is empty. So let's add some stuff here. So it's already running on OpenShift. Post. Now I will send something about to this URL here. Name equals beer quantity 2. It is, and now up here I have my beer. So now my shopping list is on OpenShift. It's already on OpenShift. So what can we do with that? Well, something nice with OpenShift is that we have this button here that will let us scale up and scale down. Let's create a second instance. There it is. We have 2 instances now. 2 instances? That's cool. Already 2 instances? Let's try to invoke it. Oh, it's empty. B, empty. We have the problem with shopping list, a split shopping list. We have 2 versions of the shopping list, mine and the one from my wife, and they never match. You know this problem, right? So we need to fix that. To fix that, we will add some data source that we will share. So I will change my code here to use some Redis, a Redis client. Well, I'm on the cloud. I don't know where is my Redis client. I didn't install it. It's running. The only thing I know is that it's named Redis. Okay, so let's take that and let's try to discover where it is. Okay, to do that, Vert.x comes with service discovery. It's built in. I will create a service discovery. It's asynchronous. Here it is. I have a service discovery object. I want a Redis data source. Redis data source dot get Redis client, which will deal with that. I pass the discovery parameter. Okay. I need some filter. Filter is filtering on records, which is a representation of a service. And what I know, its name is Redis. Okay, Redis. That should be fine. And once I have this, well, let me check if I have a service or not that is matching. If here I say, oh no, no service. So I cannot really start because the service is not there. Or if I have it, then I have my Redis client here. Once I have my Redis client, which is going to be a field, please be a field, okay? Up. Oops. Yes. Check. This one. Now I have my Redis client, which is connected to my data source that is called Redis. Wherever it is, I don't care. I just discovered it. And once I have this, I will start the HTTP server. Okay, now I need to remove my list to read and write to inside this Redis client. So don't worry, the Redis is very easy to use. To delete, I will need a constant first. So Redis, if you don't know it, it's key value distributed store. And the key, or where I will write my shopping list, will be named shopping. So that will be my key. And here, I will do redis.hashdel, the key, the name. I don't care about the result. And I will just do this. That's what I have to do. All the interaction, because it's Vert.x, are synchronous. Here, to add to list, we need to replace this part, right? Hash add set, sorry. Key, or then it's the name. So the API is a bit annoying because quantity has to be a string. It's our API that is like that, so I will do integer.toString quantity. Then I will have some result. I don't care, I told you about the result here. And then I just do this. Again, it's going to be asynchronous, but completely non-blocking. And here, well, here it's even easier. Give me all that I have. This is going to be an async result. If I don't have anything, that means something really bad happened. So if something really bad happened, I would just do routing context.fail with the cause. And if I have something, I will just do routing context dot and response dot and my JSON, so my result, and that's all. Here. Now normally all my code is non-migrated to Redis. I wrote what, 10 lines? Let's redeploy that. Oops. I'm executing the same code, so that will rebuild here locally the projects and everything back. Every object that has already been created because OpenShift implement in the idempotency won't be recreated because they exist already. So it should be fine. Let's have a look at what's going on here. It's probably a build that has been started. Yes. Oops. Shopping completed. So okay. Okay, what it is doing here is that I had two instances, and now it's doing a rolling update. It's starting the new instances, and one is ready, we will define that. Then it's turn off the other one, and then start the new one. So it's really doing a rolling update. And now if I have this, yeah, not on localhost, obviously. So it's empty, because, well, my Redis database is empty. So now I'm going to add stuff again. Here is my beer. Back. So what we had is, let me check if everyone got the same one. Yes. Everyone got the same one. I see that you may not believe me here. So let me add something. Here, I will add a header that I will call x served by, and I will write the name of the pod that is serving the request. Host name, okay. I'm also going to do something is that when we do the rolling update, there is some downtime. Why? Because it doesn't know when the pod is ready. When are we ready to serve request? So we are going to change that too, and before redeploying, I will just say, remember I have my slash that just say hello. I will go to my deployment config. I will say add health checks. OpenShift has two types of health checks: readiness probe that are used in rolling update, and liveness probe that are used to be sure that we are still alive. So readiness probe, well, that's very simple. It will try the rolling update, but won't turn off the first pods until the first one here is ready. So to create that, it's fine. The default configuration is fine. And liveness probe, OpenShift will ping this periodically, and if you don't reply, it say, wow, you're dead. And then it will kill your container and restart. So it's a resilience pattern built in. We will try this. So now I have my two health checks, probes, and I will deploy here. Same thing again. So normally now, when I will emit my request, I should have this header that says X served by pod 1, pod 2, and we will see that it's implementing a load balancer. What I have, the URL I have, is the URL of my service. I don't care how many instances I have behind. It's implementing the rolling update for me. So if you were on my reactive landscape talk, it's really the message. We're sending a message to this URL, but behind this URL is not one guy. It can have 1, 2, 3, 4, 10 guys, and it will do that for me. I don't know which one is going to serve my request, and that's why I've added this header to show you which one. So, go back here. Okay, it's already done. Ooh, that was fast. So normally we should have seen some not ready. We will see that later. And now, if I go back here, I do my shopping. R Cody needs to E. R Cody needs to E. R Cody needs to E. There is a load balancer built in. I didn't have done anything, right? So I have my two instances. So I can, if I have much more loads, then I can just create new instances and so on. One thing that is nice too is that I can go to my pod here. This one, for example, I have the logs. So the logs that we've seen here is that it's dealing with Kubernetes to retrieve all the services. We can go to the terminal. Yes, we have a terminal. What do we do in a terminal? In terminal, we do PS. We found, oh, this process looks cool, right? Boom, let's kill it. Disconnected. But OpenShift monitors that for me, and it already recreated it. So if I go there, you see container restarts. So it found that I've killed the process because I have this liveness probe, and it said, while you're dead, I restart you. That's a resilience pattern too. I didn't do anything, right? I just deploy things, do a script that you will have access to it, so don't worry. And you will see there is colors and stuff like that. It's because I'm getting old. And it's restarted, so that's pretty cool. Okay, that's my shopping list, but no, someone told me that would be cool that in your shopping list you have the product, the quantity, and the total price. And for this, I will need a pricer service. So fortunately, I already deployed a pricer service that I found, let's say, on the shelf. I didn't implement it. It seems very randomly, but it's here. Okay, that's his pricer service, and let's try to use it. So I'm going to do something different. Instead of using Docker here, I'm going to use the Fabricate Maven plugin. So I already prepared that because that's a lot of XML. The Fabricate Maven plugin will do everything that I was doing with Docker for me. And actually, it's not doing the Docker thing, it's using the source to image, which is a much better way. So it's sending the file jar to OpenShift and package that inside the image. And all the image that use this S2I, source to image, looks all the same. That's all. Nothing else is different here. How it works is that this plugin knows that I'm going to use a Vert.x Maven plugin, detect it, and because of that knows that it's going to be on this port, it's going to be a Vert.x app, and so on. So they are combined all together. But I need to write my cool service that will do, so call my pricer and my first service to get this shopping list with more details. But for this, it could be a bit complicated, right? Because I need to call first service, then from this I need to call my pricer. My pricer needs to know the name, and then get me the price. So it's such a lot of service to orchestrate, and I must be non-blocking because this vertex. How does that work? Well, that works with callbacks or with Reactive Java. And look what I did. I've added that to my package. Because all the Vertex API, we have the Reactive Java binding out of the box. We will see why we have this. I need my start method as usual. I will do a router, but this time, look, I will select this Reactive Java router. Router vertex, okay. I will have a single route on slash where I will do this get shopping list. Let's create it. I want, yeah, let's do that. And now I need my pricer service and my shopping backend service. So I will need some service discovery. Again, I use the RX version of it. Create. Oops, discovery. And now I need my two services. But I want to do that in parallel. I don't want to have one service and then, oh, let's look at the other one. I will lose time for that. I just want to emit, hey, give me this, and when you have both, call me. We can do that, but to do that, we will use Reactive Java. So I will just do, so in that case, it's HTTP endpoint, and I will retrieve web client, which is my HTTP client for Vertex. Discovery. I have to write my a filter. The first one is my shopping backend. So I know the name again. Obviously, I do on the name, but you have other possibilities, and you can do on whatever, anything. That's all. I don't have to put a callback here because this is returning a single. A single is an observable of one element. We will see why we do that. I will copy this because I need the pricer service too. Let's call it stew. So I have these two singles, which are more or less the action to retrieve it. So now I will just do, well, call me when you have both. And when you have both, execute this. Oops, obviously I'm not at the right. Much better here. So shopping is going to be, so all the results of my single, so the value will be passed in this thing. So X will be my shopping service and Y will be my pricer service. Okay, and when I have that, I will create my HTTP server, as we did, router. Because we have retrieved the two services, we are fine. We can actually start. Okay, and listen always on the same port. We can always open on the same port because we don't care. We are running inside container, so everyone is listening on these things. And what? Oh yeah, return. Again, this is returning a single. It won't execute anything if I don't subscribe to it, because I need to observe, so I need to subscribe it. I don't care about the results, so I will just say, well, subscribe, do whatever you want. So now, let's check if we have something. To deploy here, I will just do fabricate deploy. I'm not in the right project, so it doesn't work, of course. So it's calling Maven. It's going to do a lot of things, extracting the metadata from my project because it knows that it's Vertex, doing everything, compiling, packaging, and so on for me. Send everything to OpenShift, say, well, it's an S2I build, take the file jar, build your image, and done. Okay, that should be fine. Yes, so if we go back here, where it is? Ooh, it's there. And that should be fine. So this is the service that I've exposed. I will create a route. because everything you do by script, you can also do them using simply this. Up. And does this work? I should have a not yet ready. Let's have a look at what it is doing. Okay, should be. Nope, not this one. Oh, let's wait a minute and see what it is doing. I'm running a bit out of time, so I won't write this method. I will just comment it. So what we are doing, in this method is that we are calling our shopping backend. So it's what I'm doing here, using the web client I'm using. I retrieve the result, so this, again, I use Eric Java for that, so I do a Eric send, I get a single of HTTP response of a buffer. Then when I have the result, this method is called here, I retrieve the body of the JSON object, and what I do is that for each entry of my shopping list, I'm calling the pricer service. And this will be very simple because of Eric Java. It's like that. Nothing is very complicated. I just do observable from my body, then for each entry, retrieve the price, which is a method that I've implemented that just do the computation of the price and return a single. As it's a single, I just have to do observable. And when I'm done, then I subscribe to it. For each line, for each service, I just write the line. And because it's a bounded stream, I will have this last event call, which is, well, you're done. So why I'm able to do that? Because I'm using a chunked HTTP response, which means that the response will be sent chunk by chunk, and when I'm done, I'm done. So I just want to be sure that this is running here. No, you don't want? So let's try with this. Why is it working? Let's try to see with this if it's working or not. Oops. Oh, it's not compiling. Ah, yeah. So if it's not compiling, it doesn't work. Oh, yeah. Copy paste issue. Okay, that should be fine. Hopefully, so we're doing the same thing. One thing that we could have done, I won't have time, is the pricer may be a bit too slow, and I want to protect me to being slow. And for this, I could have used a circuit breaker. Vert.x proposed a circuit breaker for that. I won't have time to show you, but the only thing that we could have done is wrap this inside a circuit breaker using the circuit breaker RX API. So I hope that this time. No, still not. You don't want to say anything? Ooh, class not. Okay, so that. If I move this here, that will be much better. Let's try. As it's not too slow, even if I'm deploying on a cloud, it's quite fast, right? So it's not something where you will have to wait 5 minutes to get the result. So here, yes, I'm running OpenShift on my machine using Minishift, but even if you use OpenShift online, it's not that slow. So it will probably take 1 minute to update and to run and to build, because Vert.x artifacts are very, very small, Vert.x is small, the API we use are small, so it's going to be relatively fast. Now let's wait, running logs, just to see. So this is Kubernetes, okay. This one. No, we don't want to show anything. Yes, that's my beer. Okay. Oh, and the pricer says 0. Interesting. Let's add another item here. That would be really cool if beer would be free. The pricer is just doing some random things. I need coffee. So I'm adding coffee, and no. Yes, oh, the coffee more expensive than beer. I love this country. This is great. Wow. So what is cool here is that look at the number of services I have. I have my backend service that exposes a REST API. I don't care, I have 2 instances. From the other side, I just discover the service. I don't care who I'm calling. I'm just sending requests as messaging. And when I have my shopping list, I'm calling another service. But it's kind of complicated because you have to emit 1 request per line. So if you try to do that with HTTP client, regular HTTP clients, which are generally blocking, you will block the thread. Here I don't. And to avoid the callback error, well, I just use Eric Java. I have one thing to add. It will be very, very fast, don't worry. That's much better like that. We'll deploy like that. Oops, no. We're deploying this one. So then with the whole Vert.x ecosystem, you can build much more resilience, but you have elasticity built in. And how it works, it's because the combination of the resilience and the deployment facilities from OpenShift with the power to build reactive system from Vert.x and its usability to use Eric Java, its facility to use Eric Java to write nice code, even if it's completely asynchronous, well, you start having kind of a cool system. Let's hope that it has. Up here. Starting again. So we didn't see much in this because while it's 1 hour, all the source code is going to be online on a GitHub repository, so I will tweet it in a couple, well, probably tonight or tomorrow morning. So if you are interested, you can just run. You will have all the instructions, and you follow it. And once it is deployed, now I should be able to do. Thank you. Thank you for your attention. And obviously, as you can see, I'm a web developer, right? So if you want to contact me if you have questions, that's my mail address, Twitter handle, and follow the Vert.x project. We have much more things to show to you, cloud, not cloud, and so on. So yeah, feel free to try and let me know if you have questions. Do I have time for questions?
Yeah, you have 10 minutes for questions.
Oh, 10 minutes for questions. Yes, here. Sorry? Oh, Eclipse. Vert.x is an Eclipse project. Eclipse is a software foundation hosting a set of projects. We are not part of the Eclipse IDE. I'm actually not using the Eclipse IDE, so I'm a really good Eclipse citizen. But we are an Eclipse project, and we are part of the runtime project at Eclipse. That's why. Another question? Yes?
How would you build security engineering, for example? Like, your example, basically, you just hold my service.
So can you speak a bit loud?
Yeah. Security, how would you integrate with, for example, a security provider?
If you want to, well, let's take OAuth, right? OAuth 2. So if you do that, Vert.x Web has everything under OAuth 2. So we provide you a configuration for most of the OAuth 2 providers, so Facebook, Google, Keycloak, and so on and so on. If you want to do some other stuff, we have what I did here in my root. Here I can add a previous handler that will be called, so because it's a chain of handler, that will say, I want to be sure that it's secured, and then you can write your own host provider, doing whatever you want. Don't implement your own security mechanism because, well, security is complicated. Use something that works. And you can redirect if it's not authenticated to a login page. And if it's authenticated, then you can show my shopping list. But, you know, my shopping list is not really, well, there is not much privacy in my shopping list. Another question? Well, thank you very much. And let me know if you have other questions. I will be around. I'm around tomorrow too. So thank you.
I have 3 stickers. First of all, please post your feedback and a rating for this talk. Second, the schedule for lighting talks has been published in a web or mobile app, so check it to know what's going on today at 6 a.m. And tonight we have a social event in the Fleda Club, so if any one of you would like to get a ticket, I think that some free tickets are still available in the main entrance, so you can check it out. Thanks. Yes, this is a ticket for it's a
Sorry?
Yesterday when you asked me about the sticker, I didn't know much more developing but very nice session.
Thank you. Take the stickers. We have stickers here, so feel free to take all the stickers. We don't want to have more stickers, right?
I got plenty more.
Well, so take all the stickers, please.
Štefánikova Street, Antoninská tram stop to the city center. Antoninská. Fleda. It's a big letter.
Can I have not one, not alone, someone?
It's button per person, so only 700 person could be the person there. So only with the button.
What time does
It starts at 7:30.
Oh, it's very, very small.
7:30.
Oh, very, very big. Depends upon
Yeah?
it.
Welcome.
Yeah, low res projector, right?
Yeah, I was about to tune it. It
Ciao.
was not perfect, but at least
Koho?
I was seeing stuff on my screen.
Yeah.
Not everything.
Jo, vy to je HDVčko, to včera bylo. Jestli ho někdo zežral, no tak to nevím. Ne, tady je. Ale nezaručuju ho, protože furt to blbne. Zkusíš, uvidíš.
Teď tady byl totální masakr od komunita, tady asi těch 3 hodin ušil.
Bylo to dobré? Už to bylo.
Ale jako jo, bylo to docela fajn. Sice jsem po půl hodině jsem se začal ztrácet, ale bylo fajn.
A měl levný pivo. Tady máš však to stejně samoplátní.
To nevypadá. No, dobrý. No, jo, dobrý.
No, je vypadá to dobrý zařešení. No.
To asi trošku roztat, jo. Posunutý.
Tam doporučujeme 1400 na 1050 jako takový optimum. Aby to bylo 4:3.
Tohle?
No, zkus to. A na ten správnej, jo. Ne, na LGD.
To mělo zrcadlit. Ne, není, jo.
1400 na 1050, jo. Teď už se ti zrcadlí.
Já myslím, že
Nemělo by to tam hlavně nic chybět.
myslím, že to je celé. Víceméně. celý to.
Tak už. Aha, ty to máš na 9. Dobrý.
Už je trvá.
Dobrý, máme ještě 4 hodiny do začátku.
Jo, fajn. Což trvá. poslední použil.
To bude poslední pak přesně, takže když to připravuješ, to si